Welcome to NeuroDriveAiReels, where the streets glow and the cars think. Tonight, we explore a world where garages are no longer silent spaces of tools and oil, but intelligent, breathing hubs of neon-lit innovation. Imagine a city skyline awash in magenta and teal reflections, where every raindrop on the asphalt mirrors the pulse of autonomous systems. Here, AI doesn't just park cars. It understands them, anticipates their needs, and choreographs a symphony of motion, maintenance, and care. In the heart of this glowing metropolis, the concept of a garage evolves. What if every parking space wasn't just a slot, but a calculated dance of precision? AI-driven parking systems transform static floors into living grids of efficiency. Lights pulse in rhythm with incoming vehicles, guiding them effortlessly, while sensors hum in harmonic alignment, predicting the optimal position to prevent congestion. Neon strips along the edges of the bays flicker softly, offering a quiet reassurance to both driver and machine. Cars glide in as if they were magnetized, corners kissing the edge of perfection, each movement informed by predictive algorithms that sense the city's tempo. These AI systems are more than spatial calculators. They are guardians of safety. In a world where streets are alive with autonomous traffic, where drones whisper above neon avenues, parking becomes a moment of serenity. Collisions, scratches, and human error fade into history. Cameras scan every surface with cinematic precision, lights glinting off chrome and carbon fiber, ensuring each vehicle is perfectly aligned, every sensor calibrated. In this smart city, your car's arrival feels like a scene choreographed in slow motion, every reflection painting a portrait of control. But the AI doesn't stop at parking. Within the glowing confines of the smart garage, predictive maintenance takes center stage. Imagine sensors reading every heartbeat of your car, the temperature of brake pads, the tension in suspension, the faint whisper of battery health. Neon indicators rise and fall like a city's heartbeat, visualizing diagnostics in real time. These systems learn not just from your car, but from thousands of others, building a collective intelligence that anticipates failure before it manifests. A warning light? Already replaced. A fluid imbalance? Already corrected. The AI becomes both mechanic and oracle, blending observation with prediction, ensuring that every ride is flawless. The garage itself transforms into a futuristic theater of motion. Robotic arms glide with liquid precision, casting soft glows over the vehicles as they rotate, align, and adjust. Tools hum with quiet efficiency, their metallic surfaces reflecting ambient neon. Every corner of the space is a data-rich environment where AI orchestrates tasks invisibly, like a painter adding strokes to a living canvas. The vehicles are not just serviced. They are choreographed into a dance of readiness, awaiting the next journey through rain-soaked, holographic streets. User experience in this cyberpunk world is equally immersive. Imagine approaching your car, the city lights mirrored in your windshield, and the garage AI greeting you with anticipatory updates. Your car is fully charged, tire pressure optimal, brake fluid replaced. Notifications shimmer across your augmented dashboard in teal and magenta, blending seamlessly with the reflections of neon advertisements and floating holo traffic signs outside. Convenience is no longer transactional. It is experiential. Every interaction feels cinematic, as if your journey through the garage were a scene from the city's living story. Yet, with great intelligence comes subtle intrigue. What happens when cars begin communicating with each other? When they share insights from predictive analytics and environmental scanning? Imagine a fleet of vehicles leaving the garage simultaneously, lights flickering in synchronized patterns, each car anticipating the other's paths, reducing congestion and accidents across the city. Traffic signals respond in real time, streets pulse with neon, and the garage's influence radiates outward. Here, AI is not just reactive, it is predictive, collaborative, and almost intuitive. Speculate further. In a few years, regulations may evolve to acknowledge AI-managed garages as autonomous entities. Could they earn certification as part of the city's infrastructure? Will insurers adjust premiums based on predictive maintenance data? The social impact is profound. Drivers begin to trust AI not only with their schedules, but with the very care of their vehicles. Human judgment blends with machine intelligence, forming a partnership built on anticipation, precision, and subtle neon-lit artistry. What if your car learned from the city itself, adapting to traffic patterns, pollution levels, and the rhythm of urban life? The garage becomes both a sanctuary and a classroom, teaching vehicles to navigate a complex, luminous world with grace. In this speculative urban theater, consider energy management. AI garages optimize not only for vehicle health, but for efficiency. Neon-lit charging stations pulse in harmony with solar arrays, energy flows along invisible grids, and battery systems learn the optimal time to recharge. Every watt is choreographed, every kilojoule is accounted for. Your car leaves the garage not only ready but balanced, aligned with the future of sustainable, intelligent mobility. The neon reflections on wet asphalt echo this harmony, painting trails of magenta and cyan behind every departing vehicle. Maintenance becomes an intimate dialogue. Imagine your vehicle whispering through sensors, "I need a check on the suspension after last night's rainstorm." The garage responds, almost conversationally, blending robotics and AI foresight. Tools glide like extensions of the vehicle's consciousness. Repairs happen proactively, invisibly, as if the garage anticipates the car's needs before the driver does. Here, time is fluid, every procedure choreographed to perfection, every reflection amplified by the city's neon glow. The mundane becomes cinematic. AI garages also foster personalization. Vehicles may adapt their settings based on driver mood, time of day, or even traffic density. A dashboard might shift from cool cyan for calm evening drives to vibrant magenta during congested neon-lit rush hours. Suspension calibrates for comfort or performance. AI-assisted lighting adjusts for optimal visibility. The garage becomes an extension of both car and driver, a smart, luminous partner in the urban experience. As the city grows, garages evolve into interconnected hubs. Vehicles share maintenance histories, predictive insights, and even preferred routes. A car leaving your garage has not only been serviced, but enhanced, with knowledge drawn from thousands of other vehicles across the metropolis. Neon trails follow every journey, a visual representation of shared intelligence, while holographic overlays map potential hazards and optimal routes. The garage's influence stretches beyond its walls, integrating seamlessly into the flow of the city itself. Consider the speculative edge. Social dynamics shift as AI-driven garages gain autonomy. Drivers begin to trust not only machines, but a networked intelligence that ensures safety, efficiency, and care. Ethical questions emerge. How much control should AI have in decisions of route selection, energy management, or predictive maintenance priorities? These are not just engineering challenges. They are cultural conversations painted in the glowing lights of neon skylines. Finally, reflect on the human experience. The act of entering a garage, once mundane, now feels cinematic. The AI welcomes, analyzes, and anticipates. Your car is ready, your ride optimized, your journey choreographed by a system that blends intelligence with aesthetic awareness. Neon reflections on chrome surfaces, the rhythmic hum of robotic arms, holographic indicators, and soft pulses of ambient light create an experience where utility meets artistry. As we leave the glowing corridors of the smart garage, consider this. In a world where cars think, predict, and care, what part of the journey still belongs to us? Will we shape the AI, or will it shape the way we move through the city, the way we experience our vehicles, and the way we imagine the future of mobility? The streets are alive, The garage is awake, and the neon city watches as your car glides into the night. So I leave you with this thought. If your vehicle could learn from every street, every mile, every reflection of neon on wet asphalt, how would it transform the way you drive and the way you live in a city that never sleeps? Have you ever thought about how artificial intelligence could shape not just our cities, but the very planets we explore? Picture a glowing Martian horizon, dust swirling beneath neon-lit skylabs, and autonomous rovers gliding with precision across red dunes. These aren't just machines, they are explorers, decision-makers, and teachers of what mobility could become in extreme environments. Every wheel turn, every calculated pause, every luminous sensor scanning the terrain carries the promise of discovery, yet also a subtle ethical question. How much autonomy do we grant to a machine millions of miles from Earth? Imagine a rover pausing at the edge of a canyon, its headlights casting neon blue halos across jagged rock formations. It must decide, proceed along a safe but slow path or take a riskier shortcut to reach a research zone faster. This is the future of AI-driven exploration, split-second ethical algorithms guiding actions where human oversight is impossible. And as it moves, data flows in streams of light across invisible networks, informing other machines, orbiting satellites, and Earth-bound scientists in real time. Every decision carries consequence. Every glow from its sensors is a silent whisper of responsibility. Back on Earth, cities breathe with neon energy, their streets alive with autonomous vehicles weaving like luminous threads through cyberpunk skylines. AI isn't just steering cars, it's planning urban life. Imagine traffic flows projected as holographic grids in the air, pedestrians moving safely through glowing crosswalks guided by predictive algorithms. Here, AI balances efficiency with human empathy, slowing vehicles where children play, redirecting flows to avoid pollution peaks, even adjusting lights to create safer, calmer nights. The city isn't just alive, it's responsive, vibrant, and ethical in ways that were unimaginable decades ago. Now, what if those same ethical principles from Mars rovers inform city planning? Picture a future metropolis where AI algorithms simulate millions of choices before a single road is built. Every neon-lit avenue, every floating transit hub, every green rooftop is optimized not just for speed, but for well-being. Social equity, accessibility, and safety are coded into the very streets. Autonomous vehicles glide smoothly, avoiding potential collisions, while drones hover silently above, delivering urgent supplies. It's a choreography of life under a neon sky, a city that thinks, predicts, and cares. But have you ever considered the moral dilemmas embedded in these systems? On Mars, a rover may encounter fragile alien formations. Should it prioritize data collection over preservation, guided by ethical parameters we wrote from Earth? In the city, an autonomous car may need to choose between two dangerous outcomes. How do we program empathy into algorithms, and how do we trust a machine to make choices we ourselves struggle with? These questions will define the credibility and acceptance of AI in every environment. From glowing Martian craters to the bustling streets of tomorrow's neon cities. Imagine the day when AI-powered urban simulations predict human behavior so accurately that traffic jams are rare, accidents nearly eliminated, and emergency responses instantaneous. Neon light reflects on glass towers as the city adjusts itself dynamically. Yet beneath this efficiency lies the core challenge. Humans must remain in the loop to set ethical boundaries, to question the machine's decisions, and to ensure that empathy is not lost in code. Technology may be capable of incredible feats, but morality still needs guidance. The city's neon glow may dazzle, but it also illuminates responsibility. Back on the surface of Mars, autonomous explorers collect mineral samples, navigate hidden ice pockets, and transmit discoveries through streams of glowing data beams to orbital satellites. Each mission tests the limits of AI's ability to anticipate risk, balance reward, and maintain ethical integrity in isolation. Meanwhile, back in Earth's neon-drenched command centers, scientists debate. Should a rover risk itself for knowledge that might benefit humanity, or is caution the greater moral good? Every decision echoes a question we will face in autonomous cars, drones, and city infrastructure. When life and progress collide, what rules govern the choice? Now, imagine urban planning that merges AI predictions with human intuition. Pedestrian paths glow softly under neon streetlights, autonomous vehicles glide silently on mirrored asphalt, and emergency services respond before an incident occurs. AI designs for every scenario: natural disasters, spontaneous events, even subtle shifts in human mood. The city itself becomes a living experiment in predictive ethics, a place where technology and humanity negotiate balance continuously. And yet, each glowing dashboard and neon street projection is a reminder: ethical AI is only as strong as the humans programming it. Have you thought about the cultural impact of these AI systems? In a neon metropolis, people begin to trust machines with life-altering decisions, from route planning to health emergencies during commutes. On Mars, we rely on rovers to safeguard scarce resources while conducting research that could change humanity's understanding of life. This trust is fragile. It requires transparency, accountability, and constant recalibration. Ethical missteps are visible in neon, reflected on polished streets, and felt in every delayed response or miscalculated move. Our fascination with AI is inseparable from our responsibility toward it. The interplay between AI beyond Earth and city planning is a lesson in imagination meeting discipline. Autonomous rovers teach us precision and risk management. Urban AI teaches us empathy and foresight. Together, they form a blueprint for how humans and machines can coexist in high-stakes environments. Every neon reflection, every glowing sensor, every predictive algorithm is a brushstroke in the evolving painting of responsible technology. Consider future regulations. Cities may require transparent AI decision-making, dashboards that explain choices in real time, or ethical audits of autonomous vehicle behavior. Mars missions may include similar protocols: decisions logged, risks justified, outcomes evaluated for moral impact. Our fascination with AI becomes intertwined with governance, accountability, and cultural norms. And in each neon-lit scene, whether a rover gliding across an alien crater or a car weaving through holographic crosswalks, we witness the marriage of imagination and precaution. Finally, let's step back. The glow of neon, the hum of autonomous engines, the delicate balance of light and shadow in cyberpunk streets, they are not just aesthetic choices. They symbolize the delicate equilibrium of innovation, ethics, and human oversight. AI beyond Earth and in our cities offers unparalleled opportunities, yet demands vigilance. Every decision, whether made on a distant planet or in a bustling metropolis, reflects the values we embed in machines. So I leave you with this question: if AI could make life or death choices for explorers on Mars or drivers in your city, how much would you trust it? And what rules would you want it to follow? Have you ever thought about what it would feel like to ride through a city where every vehicle moves on its own, guided by intelligence rather than instinct? Picture a bioluminescent metropolis at night, streets alive with flowing, glowing lanes, autonomous vehicles gliding silently along luminescent traffic paths, leaving soft trails of light behind them, and pedestrians moving with a rhythm anticipated by predictive AI. The city doesn't just function, it pulses, breathes, and shimmers with living light, each vehicle a moving node in a network of thought and bioluminescent motion. Imagine stepping into a car where the steering wheel feels almost ceremonial, not functional. Sensors track every object, every pedestrian, every moving shadow in real time. The car makes decisions in milliseconds, slowing for a child darting through a glowing crosswalk, adjusting speed as a drone passes overhead, navigating around obstacles with fluid grace. Each movement leaves reflections on wet asphalt, luminescent streaks dancing along polished metal. Its efficiency wrapped in luminous beauty, yet every instant carries ethical weight. What should the car prioritize in a split-second decision? Safety, speed, legality, or human emotion? Now consider the societal implications. Fully autonomous driving could redefine how communities interact with transportation. Streets could be narrower, parking lots smaller, and highways redesigned for constant flow rather than stop-and-go traffic. Bioluminescent sidewalks may expand into parks or pedestrian zones as AI coordinates vehicle movement with perfect precision. The car isn't just a vehicle anymore. It's a civic participant, part of the city's living rhythm. But this transformation isn't without questions. How do we balance privacy with data sharing? How do we ensure AI respects cultural norms and pedestrian priorities in every glowing, pulsating district? The technology itself is astonishing. Autonomous vehicles equipped with neural networks learn from every interaction. A car navigating a rainy, bioluminescent street might adjust its braking pattern based on thousands of previous encounters, predicting slippery curves, erratic pedestrians, and shifting behavior of other vehicles. It's empathy coded into algorithms, a synthetic intuition honed by luminous experience. And yet, this capability introduces dilemmas. If an accident is unavoidable, how should the AI choose? Which life does it protect, and which does it risk? These aren't just philosophical questions. They are operational imperatives that could define legal standards for the next decade. Imagine your daily ride transformed into a smooth journey across glowing highways where traffic jams are a relic of the past. People could work, relax, or socialize in fully autonomous pods, their interactions enhanced by augmented reality windows, reflecting a bioluminescent city that adapts to their mood. Cities themselves might evolve, vertical transit corridors, glowing sky lanes for flying autonomous taxis, dynamic lanes that shift based on demand. Communities once separated by geography may merge seamlessly as AI ensures accessibility, efficiency, and safety. The rhythm of life itself becomes algorithmically enhanced, streaming like bioluminescent veins across the urban fabric. Ethical considerations deepen further. In a world where vehicles operate without human input, moral responsibility shifts. Who is accountable if a fully autonomous car makes a wrong decision? Manufacturers, programmers, or the AI itself? And how do we program ethical consistency into a system capable of billions of micro-decisions every second? Streets glowing with soft, living light become theaters for moral philosophy as much as mobility. Human trust and technological capability intersect in every turn, every lane, every shimmering reflection on glass and metal. Imagine emergency scenarios. An autonomous ambulance navigates congested streets at glowing speed, rerouting in real time as pedestrians and vehicles respond to predictive cues. Its AI must balance efficiency and safety, saving lives without causing harm. Meanwhile, delivery drones glide above, synchronized perfectly with ground vehicles, leaving trails of bioluminescent light, creating a ballet of motion that would overwhelm human coordination. One misjudged calculation could ripple across the luminous cityscape, reminding us that perfection is aspirational and oversight remains essential. Urban planning itself could evolve alongside AI driving. Picture dynamic cityscapes where buildings, streets, and public spaces respond to traffic patterns predicted by autonomous vehicles. Bioluminescent signage could adjust to minimize driver distraction, streetlights pulse in harmony with traffic flow, and sidewalks glow to guide foot traffic safely through complex intersections. AI could simulate entire cities before construction, predicting congestion, pollution, and safety outcomes. Each reflection of light is a data point, each street a living laboratory, each decision a negotiation between technology and humanity. Consider accessibility. Autonomous vehicles could grant mobility to the elderly, disabled, or those without licenses, creating more equitable cities. Streets and crosswalks glowing softly with bioluminescent light become accessible to all, enhancing safety while preserving efficiency. On the other hand, reliance on AI could erode human driving skills and judgment, raising questions about independence and adaptability. Trust in AI becomes cultural as much as technical, a luminous thread linking human expectation with machine reliability. And what about privacy? Fully autonomous vehicles generate immense data, visual, locational, behavioral. Glowing dashboards may display augmented reality ads, predictive routes, or safety alerts, all personalized in real time. How do we balance personalization with surveillance? Every luminescent reflection may reveal insights about passengers, creating opportunities for innovation and abuse alike. The ethics of AI mobility are inseparable from the ethics of data stewardship, turning every street into a corridor of choices beyond just transportation. Autonomous driving won't just reshape one city or nation, it will influence cultures, economies, and infrastructure worldwide. Glowing highways in one bioluminescent metropolis could inspire networked cities across continents, while lessons learned in AI urban planning ripple into future space colonies, extraterrestrial mining sites, and orbital habitats. Ethical algorithms designed for Earth may inform decisions on Mars or the Moon, highlighting a convergence of human responsibility and technological capability across worlds. Finally, reflect on the human element. Autonomous vehicles promise efficiency, safety, and new experiences, but they are only as good as the ethical principles guiding them. Each glowing street, each bioluminescent skyline, each autonomous pod moving in harmony with the city is a testament to our choices, the trust we place in machines, the boundaries we set for innovation, and the values we encode into every algorithm. Technology and humanity dance together, a luminous ballet of decision, reflection, and responsibility. So I leave you with this question. If every vehicle on your street could make life or death decisions faster than you ever could, how much would you trust it? And what rules would you want it to follow? Have you ever imagined a world where your car isn't just a vehicle, but a living node in a citywide conversation? Picture a neon-soaked metropolis at dusk, glowing streets reflecting holographic signs, autonomous vehicles gliding smoothly along bioluminescent lanes, and every car communicating silently, instantaneously, with every other vehicle around it. The city doesn't just function, it hums, pulses, and flows as if alive, each car exchanging data, predicting motion, and adjusting its path in a symphony of glowing precision. Imagine stepping into your car, the dashboard bathed in soft cyan and magenta light, sensors scanning the streets, pedestrians, and even the micro-movements of nearby drones. Your car knows when the vehicle ahead is slowing, when a pedestrian will step off the bioluminescent crosswalk, and even when a distant intersection will light up with traffic congestion. It adjusts in real time, braking, accelerating, and guiding itself with a grace and fluidity that feels almost organic. Trails of luminescent light follow each car as they glide past, reflecting on wet asphalt, creating a living map of motion across the neon cityscape. Now consider the implications. Car-to-X communication, or V2X, vehicle-to-everything technology, allows vehicles to exchange data, not just with each other, but with traffic signals, road sensors, and even city infrastructure. Imagine traffic lights that glow dynamically, pulsing in sync with traffic flow, or highways that shimmer with light patterns indicating the optimal speed for every lane. The city itself becomes a living organism, responding and adapting to each car's needs, and each car contributing to the rhythm of the urban environment. Think about safety. Split-second decisions are no longer left to human reflexes alone. If a vehicle ahead detects a sudden hazard, a cyclist weaving through glowing streets or debris on a wet lane, it communicates instantly to surrounding vehicles. Cars coordinate braking and evasive maneuvers in perfect harmony, a glowing ballet of movement across neon asphalt. Every light, reflection, and trail tells a story of data, prediction, and shared decision-making. Accidents that once took seconds to occur can be prevented in milliseconds. But this technology isn't just about safety, it's about efficiency. Picture your commute, vehicles communicating in real time to eliminate stop-and-go traffic. Traffic jams become memories as cars dynamically adjust routes, speeds, and lane positions. Bioluminescent lanes shift and pulse to indicate optimal paths. Flying autonomous taxis glide above, synchronized perfectly with ground traffic. The city flows like liquid light, a cyberpunk river of motion guided by invisible intelligence. Every street, every intersection, every neon-lit corner is connected in a vast network of predictive knowledge. Car-to-X communication also opens new doors for urban planning. Imagine streets designed not for humans alone, but for networks of intelligent vehicles. Dynamic lanes glow to indicate temporary changes, sidewalks light up to guide pedestrians safely, and parking spaces communicate availability in real time. Cities could shrink or expand road capacity on demand, and streetlights pulse with bioluminescent patterns that harmonize traffic flow. Infrastructure and vehicles are no longer separate. They are components of a glowing, synchronized system, a city breathing with intelligence. Social implications are equally profound. Autonomous, communicating vehicles could democratize mobility. The elderly, disabled, or those without licenses gain freedom, moving safely through neon-lit streets guided by intelligent networks. Communities once separated by geography or traffic inefficiency could merge seamlessly. Yet, this reliance on AI and communication networks raises questions about privacy, trust, and dependency. Every car is a node in a glowing web of data, and every movement leaves a digital footprint. Who controls the network, and how is trust maintained across billions of instantaneous interactions? The technology itself is a marvel. Vehicles use sensors, LiDAR, radar, and AI to communicate with each other at lightning speeds. They predict hazards before humans can perceive them, negotiate intersections without traffic lights, and anticipate changes in city infrastructure. Imagine an intersection lit with bioluminescent signals that dynamically adjust as approaching cars talk to each other. Vehicles slow or accelerate with subtle precision, leaving luminous trails that map the choreography of motion in real time. It's safety, efficiency, and elegance wrapped in a glowing neon glow. Yet challenges remain. Communication networks must be secure, resilient, and ethical. Imagine if a malicious signal interfered with traffic coordination. How do we safeguard trust? How do we design AI systems to make fair, ethical decisions when multiple paths or lives are at stake? The neon city is beautiful, but it is also a web of responsibility. Regulatory frameworks must evolve as fast as the technology, balancing innovation with safety, efficiency with human values. Every bioluminescent reflection becomes not just an aesthetic choice, but a symbol of shared responsibility. The future could extend beyond Earth. Imagine Martian or lunar colonies where autonomous vehicles communicate across glowing engineered roads. Each rover, each transport pod, each flying drone exchanges data to optimize travel in extreme environments. Lessons learned in cyberpunk neon cities on Earth will inform AI-driven infrastructure across worlds, blending human ingenuity with predictive intelligence and luminous guidance. Consider the human experience. Commuting may no longer be stressful. Instead, travel could become seamless, immersive, and even beautiful. Augmented reality displays could overlay glowing navigation cues onto windows, guiding passengers safely and elegantly through the cyberpunk cityscape. Pods could anticipate passenger needs, adjusting lighting, temperature, and speed in harmony with external traffic and internal comfort. Every journey becomes a collaboration between human and machine, between choice and algorithm, between neon reflection and bioluminescent trail, and the cultural impact is just as profound. Cities filled with glowing vehicles communicating in real time could redefine how societies understand mobility, trust, and public space. Urban life becomes a networked dance of decision-making, every street and highway a luminous ecosystem. Humans must adapt to coexist with intelligent networks, learning to trust their vehicles while questioning, reflecting, and guiding the ethical frameworks that govern them. The city is alive, and we are both spectators and participants. Finally, reflect on the global possibilities. Autonomous communicating vehicles could reduce accidents, emissions, and congestion worldwide. Networked intelligence could allow cities to share data and optimize mobility across continents. Bioluminescent highways, neon-lit traffic hubs, and glowing urban arteries could create a new era of safety, efficiency, and aesthetic wonder. But all of this depends on choices we make today, the algorithms we trust, the infrastructure we build, and the ethics we prioritize. So I leave you with this question. If every car on your street could communicate instantaneously, anticipating hazards and traffic flow with perfect precision, how much would you trust this network? And what rules would you want it to follow?